Welcome friends. Today we are going to learn gear metrology. In gear metrology, we are going to start with types of gears. So let us see gear metrology. Gear. Power transmission is the movement of energy from its place of generation to a location where it is applied to perform useful work. So power transmission and motion transmission, this is the basic function of a gear. Basically, one question comes to our mind, that is, what is mean by gear? So simply, gears are defined as toothed wheels which can transmit the power and motion from one shaft to another shaft by means of successive engagement of teeth. Gear drive is a positive drive and it is provided when the distance between the driver and follower is very small. So this is what is the basic definition of gear as well as the application of gear. A gear is a component within a transmission device that transmits the rotational force to another gear or device. Let us see the types of gears or classification of gears. So gears or the toothed wheels, they are generally classified as per the position of axis of the two shafts between which the motion is to be transmitted. So according to the position of axis of the shafts, first is parallel shafts. In that case, spur gears, helical gears and rack and pinion. Shaft position is intersecting, so bevel gears. Third one is non-intersecting and non-parallel types of shafts. So depending on this position of shaft, the gears which are classified, they are worm and worm gears. So let us see here spur gear. Teeth are parallel to the axis of rotation in spur gear. They transmit the power from one shaft to another parallel shaft, and spur gears are used in electric, screwdriver, clock, washing machine and clothes dryer. Here I have shown the figure of external and internal spur gears. The spur gears which meet them externally, so those are external spur gear. The spur gears teeth which meet internally, those are internal spur gears. See here, I have shown a figure of gear. Gear axis is shown as center line and the teeth are cut parallel to the gear axis of rotation. And in second figure, driver and driven gear, that is A and B, they are meshed with each other, they are shown. Let us move further. Helical gear. So the teeth on helical gears are cut at an angle to the face of the gear. See here, this gradual engagement makes helical gears operate much more smoothly and quietly than the spur gears. So noise in case of helical gears is very less as compared to spur gears. This is what is one figure of spur gears. Rack and pinion. Let us see. I have shown a figure of an assembly of rack and pinion. Rack and pinion gears are used to convert the rotation, means from the pinion, into the linear motion, that is of the rack. So rotation motion is converted into linear motion by making use of rack and pinion. A perfect example of this is the steering system in many cars. So whatever steering system is there with many cars, that is the example of that employs the rack and pinion. Straight and spiral bevel gears. Let us see here. I have shown a figure of, first figure is straight bevel gears and second figure shows the spiral bevel gears. So see, this is what is how they meet, how they are assembled. They are used in differential gearbox of bus, trucks, etc. Worm and worm gears. So this figure shows the worm and worm gears. The worm and worm gears, they are generally employed when the shafts are non-intersecting and perpendicular shafts. So they are used in lathe machine for movement of saddle along the axis of workpiece. This is one example. So here are few references which you can refer for further reading.